Alright, so limits, continuity, and differentiability. Now, these things are all linked together because they suggest something. If a limit exists, then it's usually continuous, and if it's continuous, it usually means you can differentiate it. Not always, but usually. Now, we talked about limits before where we looked at what happens. Now, there's something called left and right limits. What that means is you either start from the graph on the left side or you start from the graph on the right hand side. Now if you have a look, there's a negative on the A. I don't know if you guys can see that from the back, but there's a negative on the A there. That means you start from the negative side. So looking at this here, if we look at the limit as x approaches 2, if you start from the left, you'll notice that it follows a line this way and then stops there. That means if you go from the left hand side, which you need a negative for, then you would actually get a value of 4. If you start from the right hand side, same thing, you look at the graph from the right, so this side, and then you follow it all the way up until you get to 2, right there, then your limit there would be 6. Does that make sense? Yeah. It just depends on which side you're reading it off. So if it's negative, start from the left. If it's positive, start from the right. And here's where you have some really odd wordings. So I'm just going to define continuous here. If it's continuous, then the limit has to exist. You have to be able to find the value there. And then, because you can find the value, f of a exists. So, if it's continuous, have a look at number 1 here. If it's continuous, you can see that it's all joined together. You don't have any points where it's jumpy. So for example here, see how that jumps? That's not continuous. If you look on the bottom here, neither of these are continuous, but be careful because you can have something like this and that's still continuous because it's joined together. Continuous just really means whether or not they're all joined together. Does that make sense? Fairly straightforward. I don't have to go through that in too much detail. Alright, so a function is defined as f of x. Now remember these are hybrid functions. Does anyone remember what a hybrid function does? If you're not sure, put it in the calculator and just have a look. If you don't remember how to put it in the calculator, I'll go through it in a second. Now, hybrid function means it's a combination of 3 different functions. That first one there is x, so it's a linear one. Second one is just a straight line. Then the third one, you have it going up. Now, this one's a little bit weird. I'll just sketch it. I know it's part 2 telling you to sketch it, but I'm just going to sketch it anyway. So the first one is x going all the way up to 1, like so. But the part that's weird is it just says f of x equals to 1 when x is only equal to 1. That means that's a dot, like I did here. Then the third part, I'm just going to use blue, that was black. Then the third part it says x squared, so it's a parabola, like that. Now looking at that, do you think it's continuous? Yeah. Yep. So I've kind of done part 2 already. Let's just write down the answer for part 2. Continuous. Alright. Now for part 1, it says calculate the limit as x goes to 1. You need to do it for both left and right. Then if they're the same value, then you say the limit as x goes to 1 is f of x. So limit as x goes towards 1 from the negative side. Looking at the graph, what do you think you will get? 1, yep, because you sub in 1, you get a 1. and then the limit as x goes towards the negative, positive side. What's 1 squared? 1. Because the limit of both sides are the same, I'm going to cheat a little. Oops. As the star is equal to the square. I can't be bothered writing the whole thing out. You're allowed to do that, by the way. See what I did on the side? I wrote down a star and a square. You're allowed to do that. I didn't make that rule up, by the way. I didn't. Normally people use 1s and 2s instead of stars and squares, that's all. Now, because the two limits are the same, then you can write down that f of x equals to 1. So I'll just put a note. If the limit of x going towards a negative is not the same as the limit going from the a positive side, then the limit as x goes to a of f of x does not exist. Alright, we'll be able to fit it. Okay? Does that make sense? I know it's a bit squished. So just make sure your left and right limits are the same. If it's not the same, then the limit doesn't exist, so you know it's not continuous at that point. Part B. So you have x squared plus x over x plus 1. State its maximal domain. How do you check the maximal domain again? Check the top or bottom? Bottom. So you want x plus 1 to not equal to 0. So x can't be equal to negative 1. So then our maximal domain is any real values except for negative 1. Because we can't have 0 on the bottom. Okay? 2. Calculate the limit as x goes to negative 1 of g of x. Do I just sub it in? No. Good. If you sub it in, it wouldn't work because you can't divide it. So factorize it first. You're left with an x, which gives you negative 1. 3. Explain why the function is not continuous at x equals to negative 1.
Because you can't divide by 0.
Yep. Because cannot divide by 0. 4. Sketch function. Now, if you have a look here, it's just equal to x. I'm just skipping back down to part 2. We have this being equal to x, so you're essentially just sketching x like so, but then at negative 1, whoops, you have what?
Nothing.
Can't be nothing. How do you show that there's something that doesn't? Which circle? Open. Good. What's the limit? Negative 1. Okie dokie. Is this part fairly straightforward so far? Alright, here's the last bit. Differentiability. It's exactly the same as continuous, except there's a description here saying it must be smooth. So, have a look at each of these. Is this differentiable? Is it continuous, in other words? No. So that's not differentiable. This one? No, because it's not smooth. Okay? If you have a sharp point, so that's commonly called a sharp point because it's sharp. Usually you just say no. This one?
Yeah.
Yes. This one? Is it continuous at that point?
Yeah.
Does it continue from the left to the right?
I can't really see the second line.
Yes. It's not continuous from the left to the right if you have a look, because it's not continuous like that. For example, there's nothing on the left side of that point. You need to have something on the left for it to be continuous. If it's not continuous, it's not going to be differentiable. If it's continuous, you then just have to check this last line, which is whether or not it's smooth. Does that make sense? Then this is the same thing. You check if it's differentiable at x equals to 1. Now, here's one more thing. If you read the slide before, the derivatives have to be the same. So, if I differentiate the first one, what do I get? Differentiating x gives me a 1. And x squared. I take the power down, what do I get in front? 2, good, and then, yep. So just plug in 1. First one you get a 1, second one you get a 2. So you can tell they're not the same. Oops. That's wrong. I can leave it derivative there, but I can't do that. So limit as x goes towards 1 from the left side gives us 1. The limit, if you go from the right side, gives you a 2. Now, I should probably briefly explain why I can't do that notation, like the one before. If you write down the differentiated form, that's fine, but notice this bit on the right here. If I wrote it down with the same notation, you might notice that it's writing down whether or not x is less than 1 or x is greater than 1, but you just want the value of 1. That's why I can't use that notation. Okay? You can still use the hybrid function notation for the derivative, but you can't use the notation for when you're taking the actual values. Okay? Just be careful with that. Anyway, back to finishing this off. Therefore, not differentiable at x equals to 1. Because they're not differentiable because they're not the same. Yeah? This whole thing is literally just checking whether or not it's the same. It shouldn't be too bad. Okay. Give the rule for f dash of x, it's on the top, and then sketch a graph of f dash of x. So then you get to 1 here. On the left side, do I use an open circle or closed circle? What does that mean? Closed, yep. So it's closed there. Then this starts at 2 if you have a look at the previous question, and goes up. Any questions? Any answers? Anyone puzzled? Okay.